Hi, welcome back to Math 533, Topics in Euclidean Geometry. In this video, we're going to take a look at a few important theorems that are consequences of the Euclidean parallel postulate. So in other words, consequences of Euclid's fifth postulate. So let's start with a definition of parallel lines. We say that two lines are parallel if they don't intersect. That's our definition that we're going to take for this class. And I will remind you, this is not necessarily the definition one takes in other contexts, right? So this is the definition for this topic of Euclidean geometry. Now we need one more condition if we are working in three-dimensional geometry, so solid geometry, and there we would need the two lines to be contained in a same plane. Since we're focusing on two-dimensional Euclidean geometry, we don't need to worry about this. And then in symbols, we write this thing with these vertical lines to indicate that little l is parallel to little l prime. And sometimes, here I have it with this vertical double line. Sometimes people write it with a slightly oblique double line. It means the same thing. Okay, and the version of the Euclid's fifth postulate that we're going to take is the Playfair postulate. So given a point P not on a line L, there exists a unique line L prime parallel to L passing through P. So here we have the line L, we have a point P, and then given these two pieces of information, little l and the point P, we now get a line L prime that I've indicated in red here that passes through P. And not only does it exist, but there's only one of them. So it is unique. I'm pointing out this uniqueness because it turns out in hyperbolic geometry, the change to the postulate that you have is in hyperbolic geometry, you're going to have infinitely many lines parallel to L passing through P. So that's kind of weird, hard to think about. We'll think about it next week. So for now, we're taking the parallel postulate from Playfair, saying that given a point not on the line, there is a unique L prime passing through P that's parallel to L. Okay, we need some vocabulary to talk about the next topics. So unfortunately, we're going to have some technical terms. You probably know most of them already, but this is just to make sure we're all on the same page about exactly what these words mean. So the first thing is a transversal to a pair of lines. So here if I have two lines, L1 and L2, a line T is a transversal to L1 and L2 if two things are true. The first one is that T intersects each of my two lines. And I'm naming the points P1 and P2. And the other condition is that the points P1 and P2 are different from each other. Right, so this is intended to rule out a situation that looks like a star. Right, if I have all three lines meeting in a point, that's no good. Right, and of course, we're not allowed to have T parallel to either L1 or L2. Right? T has to hit both of them. Okay, and then once I have this arrangement with two lines and a transversal to my two lines, we have a bunch of angles that are of interest. The first kind of pairs of angles we're interested in are these so-called alternate interior angles. So those I've indicated in red. We also have something called corresponding angles. So the corresponding angles I have in the dashed blue there. And then I will point out, of course, that we have two pairs of alternate interior angles. Right, those I just drew in there in red. That's another pair of alternate interior angles. And we similarly have other other pairs of corresponding angles. I'm not going to draw all of them. It'll make my diagram way too cluttered. Okay, another key piece of language we have is a linear pair. So a linear pair is what happens when I have a ray like so, a ray here, and a ray here, and I want the two bottom rays to be opposite. So let's say I have A, and here I have B, here I have C, and here I have D. Right? If I have that A is between A and D, then we say that angle BAC and angle CAD form a linear pair. Right, so that's what a linear pair is. And then we're going to say that supplementary angles, we'll say, let's say BAC, and I want three letters I haven't used yet, so let's say DEF. These are supplementary. If they are congruent to a linear pair. So in other words, this is if the angle measure sums to 180. Right? That's what this is telling us about supplementary angles. So supplementary angles have angle measures that sum to 180, and a linear pair is actually two angles in this geometric arrangement that I've drawn for us. Okay, another important object we have are what are called vertical pairs. So here you imagine having a vertex, let's say A, and over here I have B and I have C, and then I'm going to put B prime on that same line, and let's say C prime on the same line. So I have A is between B and B prime, and A is between C and C prime. Right, remember, this star notation means that A is between those two. Then we say that the angle BAC and angle B prime AC prime are a vertical pair. Okay, if I have one vertical pair, right, so I'm going to label it maybe like so. But we can also see we have another vertical pair. And so in that same picture, we also have that CAB prime and BAC prime also form a vertical pair. Right, so this idea of vertical pair, the story that I read in the book. So this idea of a vertical pair, vertical doesn't mean the sort of up and down idea of vertical that we're talking about. It is an adjective that means having to do with a vertex. And the vertex that's relevant is the intersection point in A. So it is a pair that's associated to the vertex of my picture. So that's where this language comes from, of a vertical pair. Though, to be honest, I enjoy drawing it the way I did, where you see it sort of up and down, but you also get it side to side. We have an important theorem about vertical pairs called the vertical pair theorem, which says that the two angles in a vertical pair are congruent to each other. So this is a very important theorem about vertical pairs. Okay, now that we have this vocabulary, we're ready to prove some theorems. And I'm going to break that out into a separate video.